Hello everyone, this is CP Edit and in this video we'll be solving this problem repeated substring pattern. So in this problem we have to tell whether we can create this original string using multiple copies of its substring. So let's get started. So for example the input is AB. So the example is A B A B. So if we choose this substring and we use this substring two times, then the string will become AB. So yes, we can create the original string using this substring. So the answer is true in this case. Now let's see what happens in this example. ABC. So you can see that we can create the original string using substring of length 3, that is ABC. So one thing that we can readily observe is that 0th character must be part of that substring which we are choosing. It doesn't make any sense to find the substring in between the string. So we can find the substring in the prefix of the string itself. So the second thing we want to observe is how many patterns that we can choose. So if let's say the length of substring is n, and let's say we have the character as a1, a2, a3. So let's say n is 6 in the first case. So a1, a2, a3, a4, a5 and a6. So in this case we can choose the substring of 2 length because we can create this plus this plus this. We can also choose the substring of 3 length. So the pattern can be this. But we cannot choose a substring of length 4 because if we do so, we'll end up with only 2 elements and we won't be able to complete the original string. So let's say what happens in n equals to 7. So it is A, B, C, D, E, F and G. So we have 7 characters in this string. So if we choose 1, we can do so. So we can choose 1. But now we cannot choose any other substring because if we choose even 2, we won't be able to, we'll be left with 1 extra character at the end. And if we choose 3, we will still be left with 1 extra character at the end. So this gives us an idea that we can only choose the pattern length which is a divisor of n. So I'm writing it here. Pattern length must be a divisor of n. So we need not check every prefix. So we won't be checking every prefix like this prefix, this, and then 3 length, then 4 length, and so on and so forth. We just need all the lengths which are divisor of n. So that gives us a very good starting point. And let's see what are the constraints. So they are saying that the constraints will be 10 raised to power 4. So length of input will never exceed 10 raised to power 4. So if we see how many factors, how many maximum factors a number of this size can have, we find that no number will be having factors more than 64. So let's see how we can do that. So what we can do is, for every divisor of n, check if the prefix of that length is a pattern. If yes, then return true. Else we can say that no pattern was found. So we can simply return false. So let's see how we can code this problem. So for I equals to 2 to square root of n, we are finding all the factors of n. So for every factor, we are checking if this is a valid pattern. So we have sent two arguments, the pattern and the string text itself, and then we'll be checking if it is if it can form the original text. So if it can, we'll return true. So one thing to note is that this for loop will be called only at most 64 times. So this for loop will not be called more than 64 times. So yes, this is accepted. So that's all for this video. See you in the next one. I hope you liked this one. Please like, share and subscribe our channel. Thank you.